Let us solve 2017 June Part B Linear Algebra question. Question number 24. Let A equals to the matrix this, then the eigenvalues of A are. Let's solve. Since sum of each entry of the column are 2 plus 1 3 plus 1 4, and sum of the second column be 5 plus 1 6 minus 2 4, sum of the third column be 5 to 7 minus 3 4. Since sum of first, second and third column are equal and equal to 4, therefore 4 is an eigenvalue of A. So option 1 is false, since minus 4 3 and minus 3, but 4 is an eigenvalue, so this option is false. Next, trace of A equals to sum 1 minus 2 minus 3, that equals to minus 3 minus 5, so minus 4. Now in option 2, trace of A equals to sum of eigenvalue 4 3 7 8 not equals to minus 4, therefore in option 3 trace of A equals to 4 minus 4 plus root 13 minus 4 minus root 13, that equals to minus 4. May or may be true. Okay, and next option 4, trace of A equals to 4 minus 2 plus 2 root 7 plus minus 2 minus 2 root 7, so that equals to 0, not equals to minus 4. So option 4 is false, so only option remain, and this is the true option. Next question, 2017 June, booklet code B. Let A be a 4 cross 4 matrix. Suppose that the null space of A is this, then dimension of column space equals to 1, dimension of column space equals to 2, rank of equals to 1, and this is a basis of NA. Let us solve. Null space NA of A is x, y, z, w belongs to r to the power 4 such that x plus y plus z equals to 0, x plus y plus w equals to 0. Since it has 4 variable and 2 constraint, so 4 minus 2 equals to 2 free variable, therefore dimension of null space of A, that equals to 2. Then by rank nullity theorem, dimension of B equals to dimension of range space of A, that equals to dimension of null space of A. 4 equals to dimension of range space of A or column space of A plus 2. That implies dimension of space of A equals to 2, and dimension or range space of A equals to the rank of A. So rank of A is 2, as dimension of RA equals to rank of A equals to dimension of column space of A. Hence option 1 is false, option 2 is true, option 3 is false, and 4 option is false, because x plus y plus z equals 0 and x plus y plus w equals to 0 both implies z equals to w. Again, x equals to minus y minus z. Let us take z equals to w equals to c1 and y equals to c2. Therefore x equals to minus c2 minus c1. Therefore null space of A can be written as x, y, z, w equals to, what is the x? X nothing but minus c1 minus c2, y is c2, c1, c1, that equals to c1 minus 1 0 1 1 plus of c2 minus 1 1 0 0. Therefore minus 1 0 1 1 and minus 1 1 0 0 are the basis of null space of A. Hence option 4 is false. Let A and B be real inversible matrices such that AB equals to minus BA, then trace A equals to trace of B equals to 0, trace of A equals to trace of B equals to 1, trace of A equals to 0, trace of B equals to 1, trace of A equals to 1, trace of B equals to 0. Let us solve. We know that trace of AB equals to trace of BA. A and B inversible matrix. Then A, B equals to minus BA can be written as A equals to minus B, A, B inverse, implies trace of A equals to trace of minus B, A, B inverse, that equals to minus trace of AB equals to B, that part A and that part B. So AB equals to BA, that equals to B inverse BA. Since trace of AB equals to trace of BA, that equals to minus trace of identity matrix into A, that equals to minus trace of A, that implies trace of A equals to 0. Next can be written as AB equals to minus BA, that implies B equals to minus AB inverse BA. Similarly, trace of B, that equals to 0. Therefore trace of A equals to trace of B, that equals to 0. Hence option 1 is true, option 2 is false, option 3 is false since trace of B equals to 1, and option 4 is false. Next, question number 31. Let A be the matrix which is 3 by 3 and I be a 3 cross 3 matrix, identity matrix, and if 6 of A inverse equals to A into A square plus B into A plus C into I for ABC belongs to R, then ABC equals which of them? Let the characteristic equation of A be determinant of A minus lambda I that equals to minus 1 to the power n lambda to the power n that equals to f of lambda. Therefore, f of A equals to minus 1 to the power n A to the power n plus a n minus 1 a to the power n minus 1 plus dot 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 plus of a0 I when A be a n cross n matrix. Now our problem is this A be a 3 cross 3 matrix and this, and in that case coefficient constant term a0 equals to minus 1 to the power n determinant of A, and a n minus 1 equals to minus of trace of A. Our problem is 6A inverse equals to A square plus BA plus CI. That implies 6 into identity matrix. Both sides multiply by A. We have 6i equals to A into A cube plus B into A square plus C into A. That implies A cube plus P by A square plus C by A to A minus 6 by A into identity matrix that equals to 0. This is the characteristic equation of the matrix A. Okay. Therefore, minus of 6 by A, this is the constant term, equals to minus 1 to the power cube determinant of A. That implies 6 equals to A into determinant of A. That implies A equals to 6 by determinant of A. That equals to 1. Since determinant of this matrix minus plus 6 0, that is 6. So determinant, since determinant of A equals to 6, as determinant of A equals to 6, therefore A equals to 1. Again B by A equals to minus trace of A, that equals to minus, what is the trace? Sum of the diagonal, minus 3 minus 2 minus 5 plus 1, so minus 4, that equals to minus 4, that equals to 4. Therefore B equals to 4A, that equals to 4, as A equals to 1. Therefore the true answer, A equals to 1 and B equals to 4. A equals to 1, A equals to 1, so this option is false, and this A equals to 1. B equals to 2, but B equals to 4, hence option A is false, option B is false, so only option 4 is true.